Hey everyone, thanks for joining. Let me just make sure this is all working and the sound's good and everything. Thanks for joining. We're going to be doing some really cool development work today. So there's my live stream. All right, now let me just share this out and let me make sure my audio is good. Sounds good and everything? Yeah, sounds good. Okay, so let me just get this shared out to my socials if you bear with me here. And also... this will just take a second to type up and then we'll get going, all right? Join me for a live dev session for a new selector tool called a new selector tool that will provide a diagram to configuration conversion using multi-stage AI and multimodal models. If you are a network engineer or into AI or want to help with prompts and diagram ideas, I will be developing live and covering the code on YouTube. See you soon. Everyone, welcome. Open, safe space. Post. Okay, so thank you for getting that going. Now let me just keep an eye on the room here and just say hello and welcome. Okay, so what we're going to be doing today, let me change screens here, is we're going to be working on a tool that is called Configuration Vision. That's the code name. The actual name we're going to be calling this is the Selector Vision Configuration Generator. So we're going to take your uploaded files, and let me just minimize some of these functions before we go over everything. And I'll explain the code first. Okay, I'll explain the code. It's less than 500 lines of code. And give me a shout out if you're joining from around the world and want to say hi. I am watching the stream. So let's take a look at the code first. This is a Streamlit app, and I'm using multi-AI. I'm using both ChatGPT's capability, multimodal capability, and Google Gemini's multimodal capability. Okay? So there's an image to base 64 function. There's an OpenAI analysis with some pretty heavy networking prompt engineering. Okay, now this takes the image the user uploads and sends it to the Mini 4.1 Mini API for image recognition. All right. Now, the next one is Gemini's equivalent, and it's just slightly different in how Gemini's API handles the code. All right, with a very low to moderate temperature. Now, what I thought I would do is, since I have each individual, and maybe I should draw this up. Let me do that. All right, so let me start a new diagram here. We're going to have, right, the user prompt comes in, which is the user's image plus prompt. Okay? And I'm going to send this to two different AIs. Right? So this is going to be ChatGPT and this is Gemini. I'm just going to say C and G. Now what I'm going to do from here is take ChatGPT's answer and Gemini's answer. Now let's call these this is going to be the initial recommendation. All right, so this is going to be the initial recommendation phase 1. All right. And I'm going to cross-reference the Google to the ChatGPT and the ChatGPT to the Google. Now, I can only do this so many times, and I'm going to call this a refinement / review, let's call it peer review. Peer review. Now, I have to ultimately have an exit point, right? And in my case, and I don't mean to, this is just through personal experience, I'm going to use Gemini Flash 2.5 at the end, which has the largest context window and is a reasoning model that I'm then going to take these two answers back and synthesize a final answer. Right, and this equals, right, the final answer to the prompt. Now, what is the final answer in this case, right? The image in the prompt. Over here, what I want is a config, or multiple configs, depending on how many devices are in the window. Hey, Robert, thanks for joining. Hey, Robert. Thanks for making it. Now, I think we're going to have a lot of fun today. Okay, so this is just the concept. And I'm going to go back to the code. So far in the code, we're at the review phases. And now we have the Gemini synthesis, which is prompt engineering, taking the original prompt, the revised prompts, the image, the original uploaded image, and some objectives to synthesize the best answer. Everything from here down is the UI and is markdown code. Streamlit code for the rest of this, the submit button and how this all works and the different phases here. So you can actually see that diagram that I made and reflected in the code and reflected in the experience. So let's go ahead and bring this up. And I'd rather up arrow than type anything. All right, so we've got this up. We're going to go to our browser. Now, I have a variety of topology diagrams. So let's first take a look at some of these topologies that I've set up. So I have a hand-drawn version. This is truly hand-drawn with some, some augmentation. I realized I forgot some information. More or less a hand-drawn napkin diagram. All right, we'll save that for the end. I have a nice, something you'd get at a Vizio with some information, a router on a stick, a larger topology with 4 devices, 2 PCs, 2 servers, 4 VLANs, 2 routers, 2 switches, okay? And I have just something I made in Draw.io, which is pretty crappy. I'm going to delete that one. We don't need that one. All right, so let's give this a go. So we're going to upload the router on a stick. And check this out. I've got some saved prompts here that I want to use because they work well. Whoops. So I'm going to simply ask this. Can you provide a recommended configuration for the devices in this topology allowing the 2 PCs to connect? Thank you. Now, I didn't use any networking terminology here. I didn't say router on a stick. I didn't say R1 or switch 1. I had no mention of VLANs or IP. It's all in the diagram, right? And I've been a network engineer for most of my life, more than half of my life, 25 years in the field as a network engineer. And it always starts with diagrams. It always starts with diagrams. And to have a tool to take the diagram, and let me just say if it gets me 85% of the way there. Let's say I get 85% of the code from a tool like this, I'm 85% closer to having those devices configured. Or I could feed this into a PyETS job or something. So let's go ahead, submit. Remember those phases, right? So OpenAI is analyzing the image and generating an initial proposal. Gemini is analyzing the image and generating an initial proposal. And then we're going to cross-reference those proposals against each other and hopefully boil out the best answer, right? So Gemini's reviewing OpenAI's config, and then OpenAI will review Gemini's config. And then Gemini will synthesize the revised configs and the original prompt and image to come up with proposed configs for these devices in this topology. Hey Dilemma, very cool to see you. Thanks for joining. Anybody has any comments, questions, please. I'm actually going to lean on you in a little bit. We're going to do the couple that I have planned, but if you in the back of your mind have some questions, some network ideas, or some things that we want to try here today, I'm more than happy to hear your thoughts and ideas on maybe how we can push the limits here. So we're doing the config review here, right? And my container is up and running. We just have to be patient. We can see everything's running. Okay, so now it's OpenAI's turn to review Gemini's config. And now we're going to synthesize the final config recommendation using Gemini. But we have multi-AI. It's like a council of oracles. We have multiple extremely proficient network engineers, so to speak, LLMs, working to review each other's work and generate initial and then final config proposals. Now keep in mind, provide a recommended config for the devices in this topology, allowing the two PCs to connect. So there's the image. I'm going to fix this. Okay, I got to fix that. Hang on. I hate to break, but I want to go find that code. What is it? Fit? No. Here, use container with true. Let me just say false here. Actually, let me just get rid of that entirely. All right, so the next time we'll take a look. This image is way too big. All right, so no, I'm still on Twitter. I didn't leave Twitter. I'm still out there. Okay, so here we go. So this is the final recommended config. But before we look at that, let's go down a bit and view the intermediate steps. Okay, so there is the final config. We'll come back to that. So this is OpenAI's first attempt. It actually gives this port an IP address, which I wouldn't do as a network engineer. It does not need that. This does not need an IP address. IP routing is a good command. IPs on VLANs. This is not the way I would do it. Now, some of the OSPF and some of this other stuff is correct, and the switch looks pretty good. Access port VLAN, port fast, BPDU. But I don't see a no shutdown command. And the router is questionable, okay? Oh, since you left Twitter, I'm sorry. Yeah, well, I miss you too. I'm sorry to hear that you left Twitter. I am still out there, unfortunately. Okay, so then here's Gemini. Now, Gemini is always better, in my opinion, and you can see it right here. Interface 0 is perfect. A description, no IP, no shut, a sub interface with a description, .1q, the right IP address, right, 192.168.10.1. Let's look up here. 192.168.10/24, and it gave it the .1. Okay, and then it gave 20.1, and it no shut those sub interfaces. So in this case, this is a good router config. I would pass that, more or less. Switch looks even better. We have the no shutdowns here. Okay, so now let's take a look at the... Yeah, I'm on Blue Sky. It's dead. It's... I don't know. I check in every once, like all the time, but I don't know. Nothing ever happens there in my circles. Nobody ever likes or comments or tags or I don't know. I feel like it's just a dead waste of time over there. Unless you have an echo chamber of people that follow you, I suppose. Okay, so here's the revisions. So now we're going to revise Gemini's revised OpenAI config, and you can see here it's kind of goofy, right? I don't like most of this. There's the revised config, and it's fixed some things here. So we're getting really close. So now let's minimize this and take a look at the final config at the very top. That was just to show your work. right? So router, host name, encapsulation, correct sub interfaces. We have the no shutdown here. Switch looks pretty good. Looks pretty good. We're pretty close. I do notice we're missing the no shutdown command on the revision. So that's just a little bit of prompt engineering away. Or did I specify to enable the interfaces? That might be right. So it could be prompt engineering. I could specify to enable the interfaces here, and that would actually force it. Or I could do it behind the scenes in the prompt engineering. Now let me try to reload this page without that. Without that setting here on the image, and see if I can get the regular sized image to present. All right, so let's try this again. And actually, let's do something pretty crazy. We're going to upload this 4 device image, and we're going to say, oops. We're going to say, can you provide all the network configurations for all the devices in this diagram? Use OSPF, please. And let me say, please enable any required interfaces. All right. This is going to be pretty crazy. So we're going to analyze, and let me get the image up because we have time to look at it. So this is the image here. So we've got router 1, router 2, each connected on ETH01, and each connecting downstream to a switch between ETH00 and ETH02. Each switch has 01 and 02 connected to hosts on different VLANs. So 4 VLANs, 4 IP addresses I've randomly assigned, and we're going to see if we can get a config to not only configure the one router and one switch, but if we can get it to give us the config of both routers with the connection between them and the connection to 2 switches and the connection to 4 hosts with OSPF. Any bets? Does anyone feel like this might not work or that they don't believe in this? This is going to be pretty awesome. And I'd love to hear where you're calling from in the world. Where's everyone? We've got like 15, 20 people watching. Let me know where you're calling from out there in the world. It would be really great to connect with you. So again, we're going through the review process now. So we already have the image analysis done. And here we're going to synthesize the final config. Now next week, I'm going to test a photograph. Yeah, verify. I could actually load up the CML instance and push these configs to make sure that it all works. I'm using my own sort of network intuition to look at the configs. But yeah, we could spin up the CML and paste in the configs to make sure that it all works. The other thing is I'm going to ask it things like, could you prevent SSH traffic from the hosts to the servers? And see maybe if it could write an ACL or something based on the diagram as well, right? Hey, Matt. Mexico City, Portland, very cool. India. So this is, okay, so they did fix the image better. That's what I wanted, was just the regular image. So here's what we've got. Now, let's jump to the thinking, okay? Or do you want to just look at the final config? So here's the thinking. On R1, no shut a bunch of interfaces, configure OSPF. So this is not close. Switch 1 looks correct, more or less. Router 2, like the OSPF's good, but this isn't going to work. 3040 encapsulation. So the switches are okay, the routers are not good. And now, so this is better. So we have our sub interfaces and our point-to-point link to router 2 and the OSPF. Okay, I like that. And then this is router 2. Sub interfaces are all correct. Point-to-point link, router ID. Yeah. Do I got a router ID here? Yeah, okay. So then we have the revised configs, and that gets a little closer, ChatGPT. Okay, so let's look at the final config. Okay, so router 1, no shutdown, trunk link to the switch. All right, so this is this link here on ETH0. Sub interfaces, yeah, and you don't need to no shut those because the parent interface is no shut. IPs are all correct, encapsulation's correct. And then the point-to-point link, ETH01 here, this link between routers, has an IP no shut, it's a /30. Right, so the other one should be .2. Router ID passive interface default, very cool. No passive interface on the point-to-point link to advertise OSPF, but don't advertise OSPF on the trunk link because it's a switch port. Brilliant. Brilliant network engineering here in this final config for router 1. Totally approved. Now, switch 1, yeah, access, VLAN, port fast, BPDU, no shut. Yeah, it even takes care of no BPDU, all right? Oh, so the question is, just hang on a second. Can you run your AI, your script through an AI to check your work? Well, watch this. We haven't got there yet, but I'm going to do that right now. So, I just want to validate the last of this. Switch 1 is fine. Router 2 is fine. Like, this would all work. Okay, totally work. So, I've added a button to explain this config. Right? So now I can run this back against Gemini. Right? So maybe I'm like the architect in the diagram, the person, right? Maybe I don't understand all these commands or the config, or I'd like another look at it, right? So here we go. Explain this config. Describes a network topology involving two routers, R1 and R2, correct. Connected via point-to-point link, correct. And linked to their respective switches, correct. Host name, Ethernet interfaces, OSPF, right? Like, it explains all of the configs that it has recommended. And then we can download the final config in a markdown file that opens up, say, in VS Code. And there's our config. Diagram to config. Right? Isn't that crazy? Isn't that fun as hell? Okay, so let's do something else. I'm going to refresh the page. And let's literally do the napkin diagram. So this is the hand-drawn diagram. And let's take a look at it. Should have all the information it needs. It's more or less the same as the last one, except it has global NTP servers and a domain server and a native VLAN. Everything else is on here, though. But I've added some stuff in the middle, okay? So let's take a look and try this napkin diagram test. Hand-drawn. Can you convert this hand-drawn network diagram into configurations for all of the devices in the diagram? Please enable all required ports. What else should I specify here? Pay attention to the... Nah, let's just leave it like that. Let's not leave the witness too much. Submit. So this is the hand-drawn one. Let me catch up other notes here. Yeah, pretty neat, right? Pretty cool, right? I'm really excited about this. And by the way, this is a tool that Selector's behind and backing and will pay for. And much like our Copilot tool, we're going to be putting this out very soon for the community and for people excited about AI and multimodal capabilities. It may work its way into our product someday, but we're looking at this as a new, a new offering for our community members. I've had this working for a very long time. So someone came up to me in Atlanta at the Atlanta event I was at and said, do you think you could take a napkin diagram and convert it into config? Now, there's already videos out there. I've already done all the videos on that. And I actually use PyETS to then push it to the network device. For a public tool, thanks for coming in, Matt. I really appreciate it. It's good to see you. What I wanted to say was, for a community tool, we're not going to be able to push this to your device, obviously. But we could give you the configs as a downloaded, zip file or markdown file. So I'm really excited to see how it does on the hand-drawn tool. And then let's play with some other protocols. Maybe we could ask it for EIGRP or static routing. If there's other network topology diagrams out there, or the ACL one, we wanted to mess with ACLs. Any ideas out there, please feed them my way. If you want to see me type in a specific prompt with one of these topologies, I'd love to hear your ideas. So we're going to synthesize the final config here. Well, this is a big one, I guess, because there's so many devices in this hand-drawn topology, right? And it's got some more stuff to synthesize, like the global settings and stuff. IPv6 with ISIS? Sure, we can try that. That's a good one. Let me let this finish, and let me just, because I do have a short memory here. V6 ISIS. That's a good one. This one is taking a while. This one's really grinding here. Now, in terms of, I won't get into that. Okay, so here we go. Ooh, it even added password encryption, no IP. That's cool. Server name is correct. That's from DNS. NTP server is correct. That's from the settings here in the middle. That's cool. Downlink to switch. Sub interfaces, yeah. Ooh, it even added a native sub interface. Point-to-point link. And look at, I have 111/30 specified here. And it's 111, right, /30. Crazy stuff. This is from a hand-drawn napkin diagram, everyone. I really want to do a whiteboard. If I had a whiteboard instead of a green screen like I used to behind me, I would literally do a whiteboard diagram, take a photo with my camera, and see if I could get it to work. So this is fully rocking and ready to go, this whole config. All this stuff looks good. And we could explain the config. And we'll just wait for the explanation, then we'll try the ISIS thing. I kind of like that visual config generator for an... Okay, so there's the explanation. Router 1, router 2, common configuration, specific configuration for each of them, common config for the switches, specific config for the switches. It even set the priority on the VLANs, by the way. port fast, BPDU guard optimized. Yeah, very nice, very nice. And then if we hit, it relies on the diagram really. I mean, at some point, it's something. It's all good. The source of truth is the diagram and the prompt, right? So you're off to a bad start if your diagrams are wrong, right? I wouldn't blame the AI for that. So there's R1, R2, switch 1, switch 2. All ready to go, everyone. Really awesome. All right, so let's try that other one. And let's do the big diagram. And I'm going to say, to your point, I'm going to say ignore the IPv4, right? Ignore the IPv4 IP addresses in this diagram and configure the devices for ISIS and IPv6, allowing all of the hosts in the different VLANs reachability. What do you think? That's a good one. That's a really good one. Thank you. Yeah, upload myself. I don't know if you saw my 3D head. Did you see my talking head that I synchronized like South Park? Anyway, there's videos of it. I made a 3D head of my face, and I have it chatting in sync with the audio like South Park because I'm Canadian. So that is out there. This is a really good question, Robert. I'm really excited to see what we get. So and I don't know. I myself am not going to be able to validate this without a little bit of work. But what we've asked for here is, right, so there should be a network between E102, E1 and 01. We're going to have ISIS running on the two routers. We're still probably going to have sub interfaces connecting to the switches. But all these VLANs and stuff is all going to be IPv6, I hope. And then we'll ask it to explain itself to us. This is the benefit of multi-AI. Oh yeah, sure, I can put them while we wait. No problem at all. Did it say I ignore IPv6? Oh, sorry, shoot. That's a typo. That should say ignore IPv4. Well, hopefully it's smart enough. Thank you. Good catch there. We'll let it finish and we can try it again. Oh, what happened? It just sort of stopped. That's weird. That was weird. Let me try that again. All right, and the image is this one. So we'll see if we can get all four devices connected over ISIS and IPv6. So that's the topology there. Yeah, IPv6 is, I love the meme about it, right? Like they've played us for fools. Addresses shouldn't have letters in them. I mean, I've been around a very long time, and every month or every year or whatever, it's all going to be IPv6 in the future, right? And now, big strides were made when the U.S. government kind of mandated it and forced it in. But I don't know. You know, it's a 50-50 thing with the V6. There's clearly benefits in using it. All right, let's see where we're at in the... Okay, so we're reviewing OpenAI's config here. And then we're going to get the synthesized answer. And I have some best tips here for you. Be specific, right? Inter-VLAN routing with ACLs blocking guest admin traffic. Mention your desired protocols. Clarify your intent design. Include the operating systems if they're not in the diagram. You're dealing with a Junos router or whatever. Describe any of your security requirements, any redundancy, specified features, and if you have a table of IPs or VLANs, to complement the prompt. Right, you want to augment that image with as much textual richness that you can to optimize the results here, right? So it should be coming up here any minute. And it's going to really, we're focusing on the routers here, right? The switches are not going to change too much in terms of the configuration. Unless maybe we actually ask for some ACLs or something. Hello. Got my big goal. Here we go. Okay, so let's take a look. Okay, so on router 1, we're going to turn on IPv6 unicast routing. That's a good start. We've got our point-to-point link. Now, are these... Who can help me out here to say whether or not this looks good? Is that right for a point-to-point link between R1 and R2? We know the IPv6, that looks good as the /127. Router ISIS point-to-point, are those the valid? Does this look okay? And so this is wrong. Okay, so let's focus on, so that's the final answer. That doesn't look right to me. ETH00 should be the port with the sub interfaces facing the switch. Unless it assumes the switch can do IPv6. No. Okay. So that choked a little bit, eh? I don't like this. This should just be a router on a stick down here to these guys. E02. I see it's confused by this image here with this link. Okay. Okay, so that wasn't the best. Let me grab that prompt again and try it with the other hand-drawn image, okay? Which is a little more clean. Let's try that again, all right, if you don't mind. So we're now looking at, instead of this one just kind of hacked out, I hacked out a bunch of management interface lines. This is a little bit more clean. Although it's all IPv4, although I said ignore IPv4. Let's just take a look. Let's give it an opportunity to use this image. Although it's technically I should, either remove these references to the IPv4. Let's see how it does. Let's see how it does. I wasn't super impressed with that last answer, but again, the image isn't super clean. I'd love to go to, here, let's just look for some network topology. Like, how would it do with a real diagram, something like this? That would be interesting to see how it actually would do with a more complex topology, right? I think you would agree. Yeah, that's not a great one. That's a spanning tree thing. Anyway, I'll keep poking around for topology diagrams that might be worthwhile trying out this tool with. In the meantime, I have a couple of more tests I want to try. I still have to get to security and ask it about ACLs and see how it does with ACLs. Which, from the diagram I was just looking at, I could say something like, please prevent a SSH traffic between PC1 or like do not allow SSH traffic from the PCs to the servers, or only permit HTTPS traffic between PC 1 and server 1 and server 2, something like that, right? And see what kind of ACLs we can get. We could actually use this one as well and see how it does with, say, EIGRP or static routes. We got a couple options here. I'm going to be wrapping things up shortly, though, after a couple more tests. Hey, Sif, how are you? It's good to see you. Thanks for joining. So, the other thing is I had this, and maybe I'll go back to it because it might keep the user a little busy. I flip-flop between showing all of the work as it goes and just hiding it. So let's take a look here. So there's the unicast routing. We have the router ISIS. We have a loopback. We have the downlink to the switch. This is all better. Okay, so awesome. So there's the downlink, and it's all IPv6 and encapsulation. There's the peer link to router 2. And there's router 2. And then the switches. I'm pretty impressed with that. Does anyone have any objections to this? I know you'd need to really read it, but this is looking pretty good. Right? I think that's pretty crazy. I should next time I'll have the CML open and see if I could plug all this in and get traffic. All right, let's try a new one. Actually, let's explain the config for this and get the AI to give us a nice review of what these sections do. And that's actually going to be a nice review for ISIS for me personally, and maybe even the IPv6 components. Let's get the AI to explain the 4 configurations it's just proposed to us. You trust me? Yeah, a lot of people are, well, it looks all right to me. Okay, so here we go. So it knows it's using v6 and ISIS as the IGP. Net identifier. Level 2 router, suitable for a backbone network. Wide metric for IPv6. Interface configs. Sub-interfaces. Dual router, dual switch setup focused on IPv6, ELAN, ISIS dynamic routing. Really wicked. Really wicked. Really wicked stuff. Okay, so now let's try some ACLs. Can you please propose the configuration for the devices in this topology? Please only allow HTTPS between the PCs and server 1, and only allow SQL to server 2. Enable all required ports. Provide the full configuration for the for each device. I try not to lead the witness too much, right? Okay. So what I'm hopeful is that, right, it knows that server 1 is a web server, server 2 is a SQL server, and we get some ACLs put in the path between PC1 and PC2. Now, where I would apply them would be on ETH0 here, the closest routed interface to the source. I don't know that you can apply ACLs at the switch level. I don't think so. I think you would need it here on ETH00 on R1 or egress on ETH01. You could deny them ingress on ETH01 here as well, but I'd probably drop them closest to source, meaning as close to PC1 and PC2 as we can get. But let's take a look. Any disagreements about that? That's how I would do it. Anyone else out there? Looking at that topology. Do I have a pen? No, I don't. All right. Okay, so Gemini's analyzing it. So we're still at the initial proposal here. And then we're going to get into the cross-referencing. I see a lot of new people have joined. Let me just go back to the Excalidraw and explain what's happening here. Right, so the prompt and image gets uploaded here. Prompt and image. We send it to Claude, or to, to ChatGPT 4.1 Mini and to Gemini Flash 2.5. We take each of the answers and cross-reference them against each other, and then send those reviewed answers into Gemini for a final review and config. So we're into the review mode here, and then we're going to get the final config. You get the image back up. And then I think I'm going to wrap it up. We'll see how the ACLs do. And then I'll let everyone get back to their Saturday afternoons. Still cross-referencing, okay. I'm really curious what it's going to do with the access control lists. If it's going to add any, we'll see. Okay, synthesizing, we're almost there. I'm going to be continuing to add polish to this. There's a couple of MCPs I'm thinking of connecting, possibly the RFC MCP, so that this tool can look out to the request for comments and get the actual, or analyze the RFC for a certain protocol before it makes recommendations. That's maybe on my list of things to try and see if it actually adds any value to the tool. I don't know if it does or not, but if the AI can reach out to the RFC and get, the actual RFC standard for OSPF or BGP or whatever. Okay, here we go. So, some cool settings there. Well, name servers, cool. NTP server, domain name. Check it out. Check it out. Now, this is on router 1. That's where I thought it should do this. And we have this extended PC to server policy. PCs to server 1. And we have the 2 subnets for the PCs that can reach the 2 subnets for the server 1. And then the SQL for server 2. Deny everything else. Permit all other traffic. Pretty neat. Pretty neat. Everything else is going to be fine and looks fine yet. Router ID. So, like I said, and now where did it apply the ACLs? Did it get applied somewhere? Right here on the sub interfaces. Okay? Which is what I said. It should be on the sub interfaces. Right here, ETH00. All right. Well, that was a pretty good test. So, thank you for spending some time with me today. This is a tool we are going to be offering soon. I wanted to do an open development session, explain the code, do a bunch of examples, interact with the community. It's nice to see everyone. Stay safe out there. And please reach out if you have any questions or comments. Thanks again for joining me today.